Page 5, once again, some more stoichiometry. This one will have limiting reagents and excess reagents. I'm still going to use this. I'm still going to use my patented 5-step process. But one thing is I'll be checking the limiting and excess reagent, extra little helpful hints. For the lab data, I'm going to be using the percent yield again. So 2 problems on this one. Step 1 is always write and balance the equation. This one I'm going to have to do it. Aluminum reacted with iron 3 oxide to give you aluminum oxide and iron. Make sure you have the right reactants and formulas so it balances correctly. If I see that I'm missing an L there. So what does it look like? Looks like I need 2 irons on this side, 2 aluminums on this side. Step 1, check, got a balanced chemical equation. Next things, read and figure out what is it that they want to know about. This one's where it's going to get trickier because there's going to be 2 numbers. But since it tells me it's a limiting reagent will have 2 givens, 2 start boxes. Both will have numbers. Both are reactants. So there's lots of information there. You have 35.1 grams of aluminum. That's a reactant, so that's going to be important. You also have 42.9 grams of iron 3 oxide. That's a reactant, and that's going to be important. The products will be aluminum oxide and iron, but they're only going to ask about what mass of iron, so the only box over here that I'm going to want to know is over there. So I have 2 givens. Step 1, write and balance the equation. Figure out, box around what I was given. You don't have to make those boxes. I'm just trying to help, figure it out in my head first. Next thing is I have to convert to moles if it's in grams. They both are. How do I convert these? Well, I have 35.1 grams of aluminum. 1 mole of aluminum is 27 grams. And I also have 42.9 grams of iron 3 oxide, Fe2O3. 1 mole of that stuff. Okay, that's 2 irons is 55.8, 111.6 plus 48, 159.6. So when I do some calculations with this, when I do 35.1 divided by 27, I'm going to get 1.41. That goes 1.41 moles of that. When I do 42.9 divided by 159.6, I'm going to get 0.27. 0.27 moles. That goes here. So I've got my BCA started. I've converted to moles. I've got my BCA set up. I've even filled in the start boxes, but the WAN boxes are going to have a little bit of special information. When I'm doing the BCA for these, I got to figure out how many moles can be made by each reactant. It's kind of like going back to the burgers and the bun. If I have 18 hamburger patties and only 7 buns, I'm going to be limited to just 7 buns. So I have to figure out how much I can make of each one with the amount given. I wrote myself a little note here that says split the box. And what that means is over here in the products, I got to figure out how much do I have enough aluminum for. Aluminum, 2 aluminums make 2 irons. 1.41 aluminums would make 1.41 irons. 1 iron 3 oxide will make 2 irons. That's twice as many. So 0.27 times 2 over 1 will be 0.54. So I have enough aluminum for 1.41 moles, but I only have enough iron for 0.54 moles. So circle the small number, cross out the big number. You're not making 1.41. You are stuck with only being able to make 0.54. How come? Because you only had enough Fe2O3 for that. That is the limiting reagent. Therefore, you have extra aluminum. Next step, to figure out how much do we have and how much extra. Kind of wish I didn't have that there. I'm going to need that area in a few moments. Okay, so What's then next? Well, I still don't even have a theoretical yield. Well, I sort of do. I can make 0.54 moles of iron, but how many grams of that is that? 1 mole of iron is 55.8 grams. 0.54 times 55.8, so I can make 30.13 grams of Fe, theoretically. Okay, so then what? Now it's the tricky part. There's not a whole lot of points on this. If I was going to make 2 moles of iron, it would require exactly 2 moles of aluminum. Well, I'm not making 2. I'm only making 0.54. So it's only going to require 0.54 moles. Well, I have 1.41, and I'm using up, minusing 0.54. So I'm going to have 0.87 moles of aluminum left over. How much does that weigh? Well, 0.87 moles and 1 mole of aluminum is 27-ish grams equals times 26.98 equals 23.5-ish. 23.5 grams of excess aluminum. Number, unit, label. Last one on this page. Still going to use my patented 5-step process. Only this time, it's lab data. And lab data, really what they're usually asking you is, what is your percent yield? How much were you supposed to be able to make versus how much did you really get? So I'm following these patented 5 steps, but I'm going to use some lab percent yield information over here. Okay. Step 1, write a balanced reaction. I don't care where you write it. I usually write it off to the right. I'm just going to write it where I would. I'll write it where it says. I'm going to put nickel and silver nitrate. Make sure you have correct formulas. Silver is going to precipitate out, and I'm going to have nickel 2 nitrate. Well, Ni has a +2 charge. Nitrate only has a -1 charge, so it's going to take 2 of those. If you see 2 nitrates on the right, I'm going to need 2 silver nitrates on the left. Since I see 2 silvers on the left, I need 2 silvers on the right. Got a balanced chemical reaction. Check. Okay. How do I figure out what's going to be important here? Well, when you go to the lab, you have to start with a reactant. And you'll end with a product. So we have to figure out which reactant and which product are they really interested in. Well, when I look at my lab data, I kind of can pick through it and see, okay, they measured a bunch of stuff like beakers, but silver is one thing that's important. That's going to be important box. And nickel is another thing that's going to be important. That's going to be another important box. They don't ask me or tell me about silver nitrate or nickel nitrate, so these are the only things. They apparently are going to tell me the given. How do I know that's given? Because it's a reactant. We have to start with a reactant. Given a certain amount of nickel, we want to know how much silver we should be able to make from the mass of nickel reacted. Okay, they had a hunk of nickel, weighed 5.25 grams. But then after the reaction, they still had a bunch of nickel left, but it only weighed 4.89 grams. Subtract those two, 5.25 grams of nickel minus 4.89 grams of nickel. And that's going to equal 0.36 grams of nickel. We had 0.36 grams of nickel that got used. I know we had more than that, but we only used that much. Box around what I was given. I already did that. The numbers that I want. I'm at the step where I'm trying to now convert it to moles. Got to go look at the periodic table. Nickel weighs 58.7 grams per mole. 1 mole is 58.7 grams. 0.36 divided by 58.7 equals 0.006 moles. 0.006 moles. That goes over here. I have 0.006 moles of nickel. So how much silver can I make? Well, 1 mole of nickel makes 2 moles of silver. So 0.006 times 2 over 1, the number that I'm trying to get to goes on top, is going to equal 0.012 moles of silver. That's how much I should get. Um, so what do I do with that number? That's not a, it's kind of a theoretical yield, but that's a theoretical in moles, and the scales are all in grams. So I'm going to go look up what silver is, and silver weighs 107.9 grams per mole. If I have 0.012 moles, and 1 mole weighs 107.9, 0.012 times 107.9, theoretically I should get 1.29 grams of silver. That's my theoretical yield. Did I? Let's figure out the actual yield. The actual yield, well, we had a beaker that was empty, and then when we were all done, I had some silver and it weighed a little bit more. The actual yield is going to be my silver information, 103.13 grams, minus the beaker weight, and that's going to be 1.08 grams silver actual. So we were supposed to get 1.29 grams. We only got 1.08. 1.08 grams actual divided by the theoretical of 1.29 grams times 100. 1.08 divided by 1.29 equals times 100 times 100. It doesn't seem right. So I'm going to redo that. 1.08 divided by 1.29 equals times 100 equals 84%. 84% yield. Last one, sketch the pH scale. Just a little bit of a reminder to you. It starts at 0, goes up to 14. 7's in the middle, that's neutral. 6, 5, 4, 3, 2, 1. All of these up to there are acids. And as you go this way, it increases in strength. The smaller it is, the smaller the number, the stronger the acid. 8, 9, 10, 11, 12, 13, and 14, all of those are bases. And as you go this way to the right, it also increases, but it increases the strength of the base, increasing strength.